Hello and welcome back. In this video, we're going to be taking a look at how to draw ray diagrams for biconcave or diverging lenses. Now this is a typo. It says diverging mirror. This is a diverging lens. Now what makes a diverging lens? Well, if I send parallel rays of light through that lens, it's going to diverge away, spread out, at such an angle that the back ray passes through the near side focal point. And of course, this can happen on both sides, therefore there are two focal points on both sides of the lens. The rules are fairly similar. We need two principal rays in order to intersect to form an image. Every refracting ray has, we're going to draw a virtual extension to it. We call that a back ray. Let's take a look at number one by showing all three principal rays and see how the intersection can occur. The first ray is going to go parallel to the principal axis. Now you're not going to refract down because this is not a converging lens. Instead, you're going to refract up, but you're going to refract up at just the right angle such that your back ray goes right back through. And I'm using the wrong colors. Let me fix this. We're going to refract upwards so that my back ray goes right back through that near side focal point. Okay, so again, just to label our pieces, the black ray is the incident ray. The blue ray, well, that's the refracted ray. And the gray dashed line, that's the virtual extension of the refracted ray that I refer to as a back ray. Okay, so it's still the first rule. The first rule says go parallel to the principal axis and refract through a focal point. Well, it's refracting in a way that the back ray goes through the focal point. That's the difference. Now, the second ray tries to go through the other focal points. What you're going to do is you're going to aim the top of the arrow, set up your ruler so that the top of your arrow aims the top of the arrow with the far side focal point. So you're aiming for that point right there. Now, you don't quite make it because as soon as you hit you're going to take this line that you have right here and back it all the way up to the lens, just like this. You don't go all the way to the focal point because once you reach the lens, you refract parallel. Just like that. And then from this, you produce a back ray, right, going backwards. And what you should notice from that, draw this over here, back ray. What you should notice is that the two gray dashed lines have intersected right at that spot right there. And I'm going to draw an arrow up to that point of intersection. And let me just show one more principal ray, but we should see something very similar. The third one is going to go right through the center of the lens, unrefracted, just like that. Right, and then the back ray goes back this way. So we can see all three back rays are meeting right at that spot. So I'm going to redraw the image location right there. And you can see, ladies and gentlemen, we're ending up with a very smaller, reduced, upright, and virtual images. Remember, virtual images happen on the near side of a lens. Real images occur on the far side of the lens. Now, for each of the remaining examples, I'm simply going to use the first ray, which always works, no matter what the lens and how far away you are from it, and the third ray, which goes right through the center of the lens unrefracted. Let's take a look. Go parallel to the principal axis. Stop when you get halfway to the lens. And refract up at an angle that allows the back ray to go backwards through the focal point. It's always going to be that way. Then set up your arrow to go and meet halfway through the lens and continue unrefracted. And you can draw, in this case, you can draw your back rays coming back from the lens themselves, like this, to back over the black. And you can see the two gray back ray dash line extensions are meeting right about there. Again, producing an upright, reduced virtual image. And so what we're going to see is we're going to move the object closer and closer, and let's see how these results of these image characteristics will change. First ray, parallel to the principal axis. Refract upwards so that the back ray can pass through that near side focal point. Go through the center of the lens, unrefracted. Draw the back ray from backwards from the lens. And you can see the image formed is again upright, reduced virtual image. But something you should notice about the image is that as we get closer to the lens, the image itself is getting a little larger. And it's moving a little bit away from the lens, but you can see that as we get closer to the lens, that virtual image is getting larger and larger each time. Now, let's see what happens at the focal length. When we placed an object at the focal length of a converging lens, no image was formed because no intersection occurred. Let's see what happens now. We're going to go parallel to the principal axis. We're going to refract in a way that bends upward. Through the near side focal point. Then we're going to go through the center of the lens, unrefracted. Draw your back ray. You can see the images form, again, an upright, reduced virtual image. Now, in the last one, we're going to move the object halfway between the lens and the focal length. Go parallel to the principal axis. Refract upward at an angle that allows the back ray to go backwards through the near side focal length. Third ray, through the center of the lens, unrefracted. Draw your back ray extension. And we can see that in each of these 5 examples, we have produced an upright, reduced virtual image. Diverging lenses are good for eyeglasses. Part of eyeglasses are curved in a diverging lens fashion.